Hi, I'm Rick Crosslin from MSD Wayne Township, broadcasting live from Carbondale, Illinois, home of the total great American eclipse. We're here with a great team. We have Eric Hartvig from WFYI, Brian Paul from the Indiana Department of Education, and my friend Justin Abner from Maplewood and his son. You know, this is going to be an exciting day today because everything is lining up just perfectly for a great total solar eclipse. So why are we in Carbondale? Carbondale is located right on the path of totality, which means the shadow cast by the sun and the moon is going to fall right through this stadium behind me. And we're going to be here to see it all and hopefully share it with you back in Indiana. Now, Carbondale is located in southern Illinois, so we're a little bit farther away from you guys back in Indiana, but you're still going to experience a great, phenomenal event. In fact, an event that speaks to us from the heavens above. The sun, the moon, and the earth all come together today in a show it's just spectacular to see, and I can't wait to see it. So let's talk about what's causing all this, and that is the sun, our sun, the star, the closest star to us. Our sun is so amazing that it gives us all the life on this planet. It gives us heat, it gives us warmth, it even gives us the weather. Without the sun, we wouldn't have photosynthesis. Without photosynthesis, we wouldn't have plants, and we wouldn't have animals to be able to consume those plants. So the sun is pretty amazing here. And today, we're going to see a special part of the sun that you don't often get to see. We're going to see the corona. Now, the corona is the outer layer of the sun that is almost impossible to see unless something blocks it out. And what's blocking out today? Our moon, Luna, who makes its trips around the Earth about every month, and it's going to be lined up perfectly for us to see that. But there is some things I want to start off right at the beginning. The sun is massive and we need it for life. It can also do damage to you. For example, if you look at the sun anytime, it will hurt your eyes. Even for a brief second, there'll be some damage to the back of your retina. So there's a couple of ways today you'll be able to observe this, and a couple of things you should not do. For example, if you have some sunglasses, just some regular sunglasses, I don't care how strong they are, they're not going to help you in today's viewing or any day. You can't watch the sun any day with sunglasses. They're great for keeping the light out of you, but not for viewing the sun. One way we're going to use it though today are these special glasses that we have that are called solar glasses, and they have special material. They have aluminum on the outside, and they're exactly the right thing to look at the sun. And even so, where you guys are going to be, you'll need glasses all day because you're never going to have a total eclipse. Now, our NASA scientists tell us here that even when we look at the total eclipse, we're not looking at the sun because the moon is blocking it. Let me just show you a little bit about the power they have here of this sun. In your eyes, you have a lens, and that lens helps magnify things. As a matter of fact, you could take two fingers and put them together like this, and if you look right through that little spot right there, try it. Go ahead, try it on your desk on a piece of paper. Go ahead and look two fingers right here. And what you'll see is the image or the letters will be magnified and jump off of the paper. That's because you're looking right through the center of your eye where your lens is the thickest. It's like looking through a magnifying glass. So if you happen to look at the sun today, it's like looking at a magnifying glass like I have right here. And I'll tell you, that's pretty powerful stuff. I'm going to see if I can do a little bit of a burn right here. And just to give you an example, what might happen or what could happen. So here we have an eyeball in cardboard, and as you can see, that really magnifies that light. And if you would look at the sun during this time or any time, it's going to burn the back of your retina. In fact, you may not feel that for maybe an hour or two, but I guarantee you it will do damage. And just as this is starting to burn a hole in the paper, that could happen to you. So today we have a lot of cool, exciting things that are going to be going on. We have interviews lined up. We have some experiments. I hope you stay tuned to this channel all day. We we are going to meet a scientist whose whole life is studying the sun. There's one other thing you can try to do today if you get a chance, and that is make what's called a sun projector or a pinhole projector. Now we have a kind of a fancy one here from NASA. This one we made in the expo hall yesterday, and not only is it a fun thing to do, on the back it tells and shows some images of how the sun, the moon, and the earth line up for a solar eclipse. And there's a small little hole right about here. And that small hole is what we can do later today, is if I put my back to the sun and I hold this hole right here, you can see projected on my little piece of wall right here a shadow. And if I move it in, you can see how that shadow, the little circle right there on the left of the card. Now that is a really safe way to view the solar eclipse, because as the moon comes across, it'll start to see that same shape right there on the shadow. So if you're not lucky enough to come all the way to SIU to make one of these at the NASA booth, you can easily make one right here. All you need is a white paper plate and maybe a small pin. And what I've done here is I put a small hole right in the middle of this one right here. I actually tried two, because you know me, I'm always going to try an experiment. I tried one with a hole punch and one with a push pin. You see them right here? Now if you're outside today, put your back to the sun during the total eclipse, and if you notice, I can get that same hole and that same shadow right there on my second paper plate. Now you might have some fun learning a little bit about focus and focal length by moving this up and down to see where it comes in real sharp. Now I tell you, if you do that, look in the middle of the sun. A scientist from the NASA booth told me that there's sunspots that they've been observing right in the middle of the sun. And you might be able to see those, or the shadow of those, as you look through your pinhole projector. And if you notice, I have another hole right in the middle. You can see that small hole right there. So another safe way to view the total eclipse, I'm hoping to go outside and look under some trees to see the leaves shooting through, and the holes that it's going to make are some dapples that will make some really cool shadows. I've heard you can even take your fingers and make a crisscross like this and use that to observe the total solar eclipse. I just want to say one more time though, some people say, oh, I can still look at the sun, only 10% is showing through. Well, I thought about this a lot. Let's say you have a campfire and it's pretty hot. Now you imagine if you put your hands on that campfire, you're going to do some damage. You're going to burn your hand. What if we blocked off or put out 90% of that campfire? Would you put your hand over 10%? No, 10% of a campfire is going to burn your hand. And in Indiana, 10% of the sun shining through is also going to do some damage to your eye. So I guess what I need to say is today's going to be an awesome day. We got a lot of things to see and do. I don't want the solar eclipse to be the last science thing you see. So let's do it safely and let's have a good time. If you take a look behind us, things are kind of quiet now, but there we're expected a sold-out arena. Every single seat will be in here, and some cool things are going to happen during the totality, which is going to last about an hour and a half. The very first contact is when just the nibble of the moon comes into the sun. We won't be able to see that. The scientists here will see it with their telescopes first, and then some of the enthusiasts with their binoculars will see it. But after a few minutes, we'll start to see that little, like someone just nibbled out of it. And that's contact one. About 45 minutes to an hour later, as it moves across the sun, things are really going to get exciting. Now, there's a couple ways to experience this. There's all kind of high-tech NASA cameras. You'll be able to see the actual totality. So why don't you just enjoy the experience? Look around. What's going to happen? Does day turn to night? Does the temperature drop? We have thermometers. We're going to check that out. Are the animals going to change? I don't know, but I'm on the lookout for a rooster that might think it's nighttime and start crowing. You might check that out around your school. I think, and I'm not sure, but there might be some raccoons coming out thinking, what's going on? This strange event. This only happens a couple times in the same spot, about every 350 years. So let's make the most of it. Let's have a safe day. I can't wait to get back and share more with you about the Great American Total Solar Eclipse.
Hi, I'm Sean Raymond. I'm Edwin Acosta. And we are 6th graders at Chapelwood Elementary in Wayne Township. There is a lot to learn about the Great American Eclipse of 2017. Did you know it would just take 90 minutes for the moon shadow to cross from Oregon all the way to South Carolina? Wow! It is traveling more than 1,000 miles per hour. Did you know? Thanks for that information. Now you know.